everyone, welcome to our channel Knowledge of Friends. Subscribe to our channel and click the bell icon for the latest update. आज हम प्रिंसिपल ऑफ प्रोग्रामिंग लैंग्वेजेस का क्लास करने वाले हैं, जो कि ऑलरेडी हम क्लास 5 कर चुके हैं. दिस इज़ योर क्लास 6 and in this before this class 6 we had completed your unit 1 and even though we had completed your unit 2 as well in the last class, and now we'll go ahead with the starting of unit 3 in this class, which is the name of the unit is the programming paradigm here. So hopefully if it is not exceeded more than 1 hour, so we'll complete this unit 3 programming paradigm in this class only, otherwise we'll be extend in the next coming class. So first of all, it's a huge request from my side to all the viewers, please go through with the subscribe button and please like, share and subscribe our channel so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. Talking about the programming paradigm here, first of all you have to know somewhat related to this, and that is your imperative language. We'll talk about imperative language in that imperative language is a procedural language which is based on moving bits around and changing machine state as well, and that imperative programs that tend to run much faster than many other types of program. And the imperative paradigm is most established paradigm, and where the parameter that passing refers to the matching of the actuals with the formals when a procedure calls occurs here. So first we'll go ahead and let's go ahead with the question here. It's a huge request from my side to all the viewers, please go through with the subscribe button and please like, share and subscribe our channel so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. So let's go ahead here further. So first we'll discuss about the topic, which is your imperative programming language, which is they had asked you about what do you understand by imperative programming language. In the terms of imperative programming languages, in the terms that the imperative or a procedural, which is the paradigm, is the closest to the structure of the actual computer, and it is the model that is based on moving bits around and changing a machine state. Programming languages that is based on imperative paradigm that has the following characteristics, and the first characteristics that I will discuss is that the basic unit of abstraction and the procedure that whose basic structure is a sequence of statements and that are executed in a succession, abstracting the way that the program counter is incremented so as to proceed through a series of machine instructions that is residing in a sequential hardware memory cells as well. Where the second characteristic is that the sequential flow of execution that can be modified by conditional and looping statement, as well as by a very low level go-to statement that are found in many imperative languages, and which abstract the conditional and unconditional branch instruction that is found in underlying the machine instruction set as well. In the contrast to the functional programming, that in which you calculate a value for by applying a function to its argument with caring how the operations are carried out, and imperative programming is closer to the machine representation as it introduces the memory state, which that the execution of the program's actions will modify. In this, that the imperative style of programming is considered to be more error prone than a functional programming, because it opens up to the opportunity for getting things wrong, and the more detailed the instructions that is given to the computer in a branch, that to a branch or write a certain value in memory, and that more likely the program will make a mistake. So some potential benefits for imperative programmings are: the first is to improve the performance, the second is to ease of that maintenance through code clarity, and the third is the interpretability with existing code as well. In the same case, that imperative programming is a style in which that the program performs the task by altering the data in memory, and this typically leads to a pattern where the programs are written as a series of statements or commands. And when we call these actions of program instructions, and an imperative program is a list or a sequence of instruction that the execution of each operation that can alter the memory state, and we consider the input-output action to be modification of memory, video memory, and or files as well. And this style of programming is directly inspired by assembly programming, and you find it in the earliest general purpose programming languages like Fortran, C, Pascal, etc. The following elements of the languages that fit into this model is that the first is that the modifiable data structure such as array or records with a mutable field. The second is the input-output operation, and the third is the control structure such as loops and exceptions as well. There are certain algorithms that are easier to write in this programming style that take, for instance, that the computation of the program of two matrices, even though it is certainly possible to translate it into the purely functional version, and in which we can take about it in which that the let's replace the vectors, and this is neither natural and nor efficient that compared to an imperative version, that the motivation for the integrations of imperative element into a functional language is to be able to write a certain algorithm in this style, and when it is inappropriate, that the two will go ahead, and that the two principal disadvantages that compared to the purely functional styles are: the first here is that the complicating the type system of the language, and the second is that to rejecting the certain programs which would otherwise be considered correct have to keep the track of the memory representation and the order of the calculation as well. Where imperative programming is the most dominant paradigm of all the other, and it is used in assembly, Java, C, Python, Ruby, JavaScript, and many others as well. Now we'll go ahead with the detailed of, and that is to discuss the examples of imperative language. So let's discuss about examples. So in the examples of imperative languages here, all the modern imperative languages that can trace their origin back to the three imperative languages. That first we'll discuss about the Fortran, Algol 60, and COBOL here, and that consequently their influences, that influential languages are often described as the foundation language as well. So let's go ahead with one on detail here. So first we discuss about Fortran. In the Fortran, that is the first examples of imperative language. In the Fortran, that the IBM mathematical formula translating system, which is the formula and a translating system, take as for and translating system from trans, so that is named as Fortran, and that is designed in 1955, has been taken from formula, this is for, and translating from the tran in 1955. So here that first successful attempt to improve an assembly language, and is still widely used for the numerical application, and has been revised to take account of the idea on structure programming, how is decreasing in popularity as well. So now talking about the second one, which is your Algol 60. In the term of Algol 60, that is your algorithmic language 1960. Algorithmic language 1960, so that has been named as Algol 60 here, that is developed in 1950s through a joint European American committee, and first a block structured language, and a first language whose syntax was defined by using BNF, and direct ancestors of most modern imperative languages here. Now talking about the third one, which is your COBOL. In the terms of the COBOL, the name of the full form is that is your Common Business Oriented Language. So common business oriented language here, which is named as COBOL here, and that is developed in 1950s and through a committee consisting mainly of US computers manufacturer, and that is designed to process the large data file and is therefore most extensively used language for the data processing. And since its initial introduction, that the language has remained broadly unchanged here. So these were the three languages that are examples of imperative programming languages. Now we'll go ahead with the detail here. Now in the terms of it, talking about another one which we have to discuss about it, and that is to discuss the imperative language construct such as variable, expressions, control flow and functions as well. So that we'll discuss about it, like imperative language constructs. So imperative language construct here, that what we'll discuss about it. So first of all, that the imperative language constructs are discussed to be as follows. The first we have is your variables. In the variables, that variables are the containers for the data object whose contents or value that can be changed during the execution of the program, and the values may change through the executions of statements such as assignments. Multiple variables that can be grouped into an aggregate such as arrays and record structs. The current value of the variables at any given time that constitute the parts of the state of a program execution at a particular time. The variable in the programs are identified by an individual names as constant, as constant, function, etc. that are also identified by a name, and these names are called variable identifier, the constant identifier, etc. If these kinds of names are to be differentiated, variable identifiers that must be mapped to the memory location, which during program execution will contain their values. If the programming languages that provides a function with a local variable, that the new instance of the local variable identifiers that are created at a function call, and this means that also new memory location that must be allocated to these, and when the function terminates, that the locations for the local instance that can again be released, and that is this kind of the memory management that can conveniently be implemented by means of the runtime stack as well. Now talking about the second one, that is your expression. In the expressions here, that the expressions are the terms consisting of constants, names and operators, and which can be evaluated to values, and in general their values depends on the current program state. Since each evaluations of an expression A that uses the current value of the variable occurring in E as well. Now we'll talk about the third one, which is your explicit specification of a control flow. Explicit specification of control flow. In this, that most imperative programming languages that provide a jump statement go-to, which can be translated directly into the conditional jump instructions of the target machine, and the higher level control constructs such as the conditional statement, if, or an iterative statement, while, do while, for that the compiled by means of the conditional jumps. And a conditional jump typically follows an instruction sequence for the evaluation of a condition, and that case distinctions, that is your switch case, that can be efficiently realized through the indexed jumps, and thereby that the jump target address that given in the instruction is modified according to the previously calculated value as well. Talking about the fourth one, which is your functions. In the same case for the functions here, talking about it, and that is that the functions and the procedures that serve as functional abstraction, which creates a new statement from a possibly a complex statement or that of a sequence statement, and a call to this newly defined statement is at the program location that execute the sequence of the statement that is specified by a definition of the our function as well. And after its completion, that the execution returned with value of that computed by a function given there is any, and if the function has a formal parameter, that the function that can be called with a different actual parameter for the implementations of the functions, and that the instruction set of the machine that should provide a jump instruction that memorizes its origin so that control can return to the location of the call, and the body of the function that must be supplied with the actual parameter at each evaluation call, that these parameters together with the instance of the local variable and are conveniently maintained by a stack style memory management, which is often supported by a dedicated machine instruction as well. Now we'll go ahead with another one, and that what we have to talk about, and this is the last constant. The first constant, as I told you about it, that is your variables, expression, explicit specification of control flow, and of course, and that is your function here. Now we'll talk about is that is another question that has been possibly asked is what do you mean by the type, by type or data type in imperative languages? So that what we have to talk about it. Let's go ahead here. Mean by type or data type. In the same case, in the imperative data type and imperative languages. So in this, a data type that is often simply type with a name or a label for a set of values and some operations which can be performed on that set of values, and the basic idea of typing is to give some semantic meaning to what are ultimately just simple bits. An object is something meaningful, that to an application data representation that refers to the organizations of value in a program, and objects in an application that have corresponding data representation in a program as well. Talking about the data representation, so data representations in an imperative language that are built from values that can be manipulated directly by the underlying machine, and values held in the machine location that can be classified into the basic types such as integers, characters, real and Boolean as well. Talking about the another one here, which is we'll talk about it, and in the same case, that is the structured types that can be built up from the similar types and are led out using the sequence of the location in the machine, and the type expressions are simply types that are used for the layout values in the underlying machine and to check that the operators are applied properly within expressions as well. Let's go ahead to discuss about it in a detail, which is your discuss basic types in imperative languages. So let's go ahead to discuss about it, which is your basic types in imperative language. So the basic types of in imperative languages, that what we have to discuss about it, and in the same case, that the basic types are as to be as follows, and the first we have is your enumeration. In the enumerations here, that an enumeration is a finite sequence of names written between the parentheses in Pascal, and that the declaration type would be like in the form of day equals to, which is your Monday, Tuesday, Wednesday, Thursday, Friday and Saturday, and of course the Sunday here. And that makes the day and enumerations with 7 elements, and names like 1 are treated as a constant, and the Pascal and C insist that a name appears in at most of the 1 enumerations as well. The basic type of the Boolean and the char is in Pascals are treated as enumeration. The element of an enumeration that is ordered, and operations on the enumerations and the Pascals we have in the order of first we have the odd x, the second we have of x, and the third we have print x here. So in the same case, these were as follows. The second we will talk about is which is integer and real. In the term of the integer and real here, that is, an integer is a number without a fractional part, and a number you could use to count things. That is, although the integer that may be also negative, and mathematicians that may distinguish between the natural numbers and the cardinal number, and a linguist may distinguish between the cardinal numbers and ordinal numbers, but these distinctions do not concern us here as well. While a real number is, for our purposes, simply a number with a fractional part, and since the computer do not typically implement real numbers exactly, it is not necessary or even meaningful to distinguish between the rational, irrational, and that is your transcendental numbers as well. Talking about the third one here, which is your Boolean and Boolean expressions. Booleans and Boolean expression. So Booleans and Boolean expression here, that the short circuit evaluation, that is minimal evaluations, or McCarthy evaluation, that denotes the semantics of some Boolean operators in some programming languages, in which the second argument is executed or evaluated only if the first argument does not suffice to determine the value of the expressions, and when the first argument of the AND function that evaluates to false, and that the overall value that must be false, and when the first argument of the OR function that evaluates to be true as well. The overall value that must be true. In some programming languages, that the libs and the usual Boolean operators that are short circuit. In the others, Java and Ada, both short circuits are standard Boolean operators are available, and for some Boolean operations like XOR, it is not possible to short circuit because both operands are always required to determine the result, and the Boolean operators table that we have to maintain towards it. So we are in this Boolean and a Boolean expression. We have a table that with meaning, and of course the short circuit as well. So let's go ahead to solve it out, that you will be getting it as well. Double and when we have this is single, we will be going ahead to understand about meaning, and then of course is that short circuit or not. So in that double AND, I will talk about it, and which is your AND. This is also an AND. This is OR, and this is also OR. When this is AND has been take place, then yes, short circuit takes place. In this, no, yes, and in this, no. So you can just say that When it is double, then it is takes place as short circuit, otherwise it is not. Now talk about the another one, and that is the fourth one which we have to discuss here, and that is in the terms of it. That is the another one we will have to talk about, that is fourth one, which is your subranges. In the subranges, that the subranges are the special cases of the basic type because they restrict the range of the values of an existing type. For example, here that is your in the terms of it, talking about the, for example, that is your the subranges between the value of 0.99 and that is your 0299, that is your 0299, and that the syntax of the subrange in the Pascal would be like in the form of that will represent it here as well. Constant, constant 2, that is so here in this, as I told you about it, and now we'll discuss about the another question, which is to discuss the sequence of element, and that is your array in an imperative languages. So let's go ahead to discuss about it, which is your sequence of element, that is array in imperative language. So in this, that an array that is a data or structure that holds a sequence of elements of the same type, and the fundamental property of array is that A of I, and that the ith element of array A here, and that can be accessed quickly for any value that I at a runtime. And an array type specifies that the index of the first and the last element of the array and the type of the all element here, that the Pascals allows the array index type to be an enumerations or a subranges as well, which is the ranges we have the array like 1996 till 2000 of real, and the array that is your Monday, Tuesday, Wednesday, Thursday, Friday of integers, or array that is your character of tokens as well. So here the first type for this we have here is that is your that is array layout. Array layout here. In the array layout, talking about this is the layout of an array that determine the machine addresses of an element like A of I, that relative to the address allocation, that is a variable A, that is your array, which is a low or high, or a T that assumes that each element of a type T that occupies the W location, and if A low that begins at location base, then A low plus 1 that begins at the base plus W, and low allow that is plus 2 as well, and in that same case that begins as the base of plus 2 abstract W, and so on. With I abstract W plus base minus low abstract W, that is in the formula of I abstract W plus that is your base minus low abstract W. So where I abstract W has to compute it in a runtime, but where base minus low abstract W that has to be can be pre-computed as well. Now we'll talk about the second one, which is your array of arrays. Array of array. In the array of array here, it is multidimensional that is array which can be a row major or a column major, and consider the two array where with the variable A that is your array low 1 high 1, and of array that is your low 2 and high 2 of T, and the variable A which is your array of low 1 high 1 low 2 high 2 of T as well. In the same case for this, that we have your row major layout and the column major layout in this, and in the row major layout that the address of A of I comma j, that is base plus I minus lo1 and abstract rw plus j minus, that is the formula we have here, base plus I minus lo1 plus rw and that is your j minus lo2 abstract ew. So there rw is the width of the row and ew is the width of an element. Example, the var m and then array 1.1 till 3 and 1 to 2, that of an integer here. In the column wise, if a column major layout, that the address of ai comma j, that is the formula we have is here, that is base plus j minus lo2 abstract cw plus I minus lo1 abstract ew here. So where cw is the width of the column and ew is the width of an element as well. So let's go ahead with the further one, and that we discuss about it, which is your discuss the record, that is your name fields in an imperative languages here. So let's go ahead in a detail. So here we'll go ahead to discuss the records, that is your name fields in imperative language. So in this, the representations of an object that may involve variables of different types, and a simple example in an indexed term that is represented as the sequence of character together with the length of sequence, and that generalized representation of the record to be as follows, and that we have here is in the form of, which is named as name 1, type 1, name 2, type 2, name 3, type 3, name 4, type 4, with the same here, and then we will be having an end. So in this, that for example, the type complex below is this record type and with two fields, that is your re and imp here, and that is the type complex is your record, that is the re is your real and im that is your real, and then we'll end up with this. This is an example of the complex below in the record type with the two fields re and imp here. That the record type of the complex is simply a template for the two fields and that re and imp, and the storage is allocated when the template is applied in a variable declaration and not when the template is described, and a change in the order of the fields of a record that should have no effect on the meaning of a program, and the operations on the record that are selections and assignments, and as well as the records that the usual ones without variants and are for representing the objects with the common properties as well. In the same case, the variant records that has a part common to all the records of that type, and a variant part that is specific to some subset of the record, that is example like type kind, that leave unary and binary as well. In the same case, that node will go ahead with the program here, so that you will be getting it in an easy way as well. So here we'll be having that sort of a shut up program that represented. So that is, this is an example, type kind equals to leave unary and binary. So in the same case, that is your node equals to record, which is c1 t1 c2 t2, and where we have case k equals to kind of, then leave, then we have unary, that is your child t3, and then we have binary, which is your child, one child, our child, that is it 4 here, and then we'll end up with here. So this is from that is a code, and in that fixed part a tag field and a variant part that we'll discuss about it. So let's go ahead with that as well. C1, C2, then K, and then we have another 3 in the same way. So here in this has been represented C1, then C2, then K. This is C1, C2, K, child. Then we have C1, C2, K, one child, and R child. So in the same case, this is fixed part. Dark field. So with the same case, that is the tag field, and that is the variant part. This is your variant part. So that comes under the variant, that is your variant part here. And in the same case, the variant record that introduces the weakness into the type system for a language, and that the compiler do not usually check that the value in the field is consistent with the state of the record. And where we'll go ahead with this, you can say that type kind equals to 1, 2, and where the T equals to, that is record case kind of, and then we have your 1, which is equals to A, and that is integer, that is 2, and which is your R, real, and of course your where X, T here. So now we'll go ahead to discuss about another thing, that is another question here, which is you explain pointer in imperative language. Pointer in imperative language. Pointer in imperative language, we will talk about it, that a pointer can have a value that provides indirect access to the element of a known type, and the pointers are used for efficiency considerations and for manipulating the dynamic data structures. The pointers are the first class value, and that can be used as freely as other values, and they have a fixed size which is independent of what they point to, and that the swapping of the two numbers that is using the pointers is to be as follows. We'll be writing a program for that, and that we have here is, that is your hash include. So I will just write it down here as well so that you will get it. Okay, I will break starting with this only. Hash include stdio dot h, then int main, then int x comma y, abstract a, abstract b, temp, which is your print f, enter the value of x and y dash n, scan f, which is %d, %d, and x comma and y here, which is your print f before swapping nx equals to %d, that is ny, which is equals to %d slash n comma x comma y. and where a equals to and x, b equals to and y, and where temp equals to abstract b, and where abstract b equals to that is your abstract a, and then of course we have abstract a equals to temp, and for the same case we'll be having a printf, which is after swapping nx equals to %d, ny equals to %d n x comma y, and then we'll return 0, and then of course the curly bracket closing. So this is a program for the pointer in an imperative language, and that what we have to deal with it as well. So let's go ahead with another one, and that what we have to discuss is your operation on pointers. What were the operations on pointers? Operations on pointer. In the operations on pointer, where the dynamic allocation on the heap performs that the following operations, and that we have here. The first we have is your new p. The second we have is your dereferencing. The third we have is your assignment. The fourth we have is your equality testing. And of course the fifth we have is your deallocation, which is your dispose p. Now we'll go ahead with the further one, and that what we have to discuss about it, and that is to what do you mean by procedure and its element. So we'll have to talk about the procedure and elements here in a detail. In the procedures and element, that the procedures are a construct for giving a name to a piece of code, and the piece is referred to as a procedure body, and when the name is called, that the body is executed, and each executions of the body is called an activations of the body. And the two forms of procedures are, that is the first is a function, and the other is a proper procedures. So in the functions one, that it can be used to extend the built-in operators of a language, and which also always returned a value, and a function that must be called from within an expression. That the proper in the proper precision here, that is the procedures, and it extends the built-in actions or the statement that is provided by a programming languages, and which is the procedure calls, and that considers the executable that statement as well. So in the procedure body, which is your function squares, integers, begin square equals to that an x abstract x, that has been represented here in the procedure body as well. We have procedure declaration that make the explicit the elements or the parts of the procedures, and that the elements of the procedures are structured follows here. The first is that the procedure name and the name of a declared func procedure, and the next is your formal parameter, which is your placeholders for the actual parameter. The third is your result type, which is your optional, and the fourth is your procedure body, which is consisting of the local declarations and the statement as well. So next we'll go ahead with the detail, and that what we have to discuss is your what are benefits of procedures here. Benefits of procedures. So in the terms of benefits of procedures here, that the users of the procedure that need to know what a procedure does and not how the procedure works. The benefit of the procedure includes the following. The first we have is your, and that is the procedure abstraction. In in the term of the procedure abstraction here, that it allows us to separate how an operation is implemented from how it is used here, and that is the term as here. In the term of the procedure abstractions here, that it allows us to separate how an operation is implemented from how it is used, and to use a procedure we only need to know how to call it and what result to expect, and we do not need to concern with the implementation as well. The second we'll talk about it, and that what we have here is to be as follows, that is your implementation hiding. In the implementation hiding, that the algorithm isolated within a procedure that can later be modified by only changing the procedures, not the rest of the program which use it. The third we have is your modular program. The modular program, that the procedure that can be used to partition large programs into the smaller pieces, which it can be more easily understood and implemented in isolations as well. Talking about the fourth one, which is the libraries. In the libraries here, that the standard collections of the useful procedures are a way of extending a language, and it is possible to write a utility reusable procedures and store them in libraries for many users to use as well. Talking about the another one, we'll go ahead with the program, which is the another question is that write a complete Pascal program with 2 functions, square and area here. That is write a complete Pascal program with 2 function, square and area. So the solution of this we have, and that is the program is to be written as follows: program trap input output bar result real function square, which is x, integer that is begin square, which is equals to x abstract x end function area, which is a comma b real colon function f, which is x real then real, and that is begin area which is b minus a abstract f of a plus f of b by 2 then end. which is begin result equals to area 2 comma 5 comma square, then write ln 2 comma 5 comma result, and then end. So this is how it is, and now we'll go ahead with another program as well, and that what we have to deal with it. And this is your another program, which is your write a complete Pascal program for finding the factorial with example. So that we'll discuss here. So here we'll go ahead with a program that the Pascal program for finding the factorial is to be as follows, which is named as function f an integer, which is integer, begin if n equals to 0, then f equals to 1, else f n abstract f n minus 1, then end. For example, it's to be as follows, like f of 3 equals to 3 abstract f of function of 2, and then we have f of 2 that is equals to 2 multiply f of 1, and f of 1 that is equals to 1 abstract f of 0, and then of course f of 0 we have 1, f of 1 we have 1, and then f of 2 we have 2, and f of 3 we have equals to 6 here. So the another question they can ask you in the terms of it here, that is what are the different methods for the parameter passing, even though that we have discussed about it. So you can go through with it, and which we had discussed in the last unit, which is your unit 2. So you can go through with that as well. Let's go ahead with another one, and that is we'll talk about the object-oriented programming, which is OOP, and that is your what are the functions and the features of OOPs as well, that we'll discuss in the detail as well. So first we'll go ahead with a short description about the OOPs here, which is your object-oriented programming paradigm, and that uses an object to design the applications and the computer programs, and that the features of the object-oriented languages, that are class, object, method, message passing, inheritance, encapsulation, abstraction as well. Inline functions, that are the function that where the call is made to inline function, and that the actual code that then gets replaced in by the calling program, and the friend function is used to access the non-public members that of a class as well. So now we'll discuss about it in a detail, which is object-oriented programming. Object-oriented programming, which is OOP. And what are the features of OOP also? Features of OOP. So that we'll discuss in the detail here. So in the same case, for that, first we'll go ahead, as I told you about some of the details about it of OOP here, that is the object-oriented programming, which is OOPs have taken the best idea of the structured programming, and that combined with the several powerful new concepts that encourages that approach of the task of the programming as well, and in a new way, in a general, when a programming in an object, that is object-oriented fashion, that you break down a problem in a subgroup of the related parts that take into account both code and the data related to the each group, that also you organize the subgroup into a hierarchy for all intents and the purposes. An object in a variables of the area that define type, and it may be seen strong at first to think of an object and which lines both code and a data on variables, and however in an object-oriented programming this is a precisely precisely the case as well. And when you define an object, you will you are implicitly creating a new data type as well. And talking about this, that is in the detail, that OOPS treats that the data and the critical elements in the program development and does not allow it to flow freely around the system, and it ties the data more closely to the function that operates on it, and it protects it from the accidental modification from the outside function. Where OOPS also decomposes of a problem that into a number of the entities that called the object, and then of course that builds the data and function that surrounds these objects as well, and where that the data of an object that can only be accessed by a function associated with that object, and how the functions of one object that can access the functions of the other object. Some of the striking features of the object-oriented programming are as to be follows: that to emphasizes on data rather than a procedure, and the programs that are divided into what are known as object, and the data structures that are designed such that they characterizes the object and the functions that operates on the data of an object on tied together in the data structure, and the data is hidden and cannot be accessed by a function as well. We're talking about that object that may communicate with each other through functions, and the new data and the function that can be easily added whenever necessary, and that follows the bottom-up approach in the program design as well. So that what we had discussed about it, and now we'll go ahead with the detailed, and that what we'll have to discuss about it, the basic concepts of object-oriented programming languages. But before that, when we'll go ahead, we'll talk about in a detail, and that in the next coming class, because it will exceed it. And first of all, it's a huge request from my side to all the viewers, please go through with the subscribe button, and please like, share and subscribe our channel, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. Let's go ahead here as well. So here with this, that what we have to cover up here and in this coming classes, as well as you will be get to know about each and every video which we had done in this till this classes as well, and that is of your data warehousing and your that computer graphics, TPMS, and as well as economics, as well as quantitative aptitude and reasoning, and even though this is your PPL, which is your principle of programming languages, where we had covered up the unit 1, which is your introduction. And in introduction we had covered up introduction, the role of the programming languages, why study the programming languages, and towards the higher level languages as well, and a programming paradigm, programming environment, language description, syntax structure, language translation issue, programming language syntax, stages and translation, formal translation model as well. In unit 2, which is your language properties, and that is we had done language properties, which is modeling language properties, elementary data types, encapsulation, inheritance, sequence control, and subprogram control as well. In unit 3, which is your programming paradigm, imperative programming, statement type, procedure activations, object-oriented programming. Here that we have to deal with the grouping of our data and operation, object-oriented programming, that is your functional programming, which is your elements, programming in a typed language, programming with list as well. And the unit 4, which is your other programming paradigm, which is your other programming paradigm, logic paradigm, concurrent programming, network programming, and language description, semantics methods as well. Now in the unit 5th, we have to discuss about lambda calculus, which is your lambda calculus, introduction to lambda calculus, and simple type subtyping as well. So first of all, it's a huge request from my side to all the viewers, please go through with the subscribe button, and please like, share and subscribe our channel, so that many maximum people can get the information at once, and even though you can also enjoy the video as well. Thank you, hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on comment box. Thank you.